Velocity vector. Average velocity vector. The average velocity vector V average, it's equal to delta R over delta T, where delta R is the displacement vector. During a time interval T, the particle moves from P1, where its position vector is R1, so this is R1, this is the position vector R1, to P2, this is P2, where its position vector is R2. So the displacement vector by definition is the shortest distance from 1 to 2. So this is delta R. Then the average velocity vector has the same direction as delta R. So V average has the same direction as delta R. Instantaneous velocity vector. V average equal delta R over delta T. When delta T tends to 0, delta R becomes tangent to the curve at 1. Observe, this is the position 1 and this is the position 2. This is delta R. When 2 become very close from 1, like this, so the delta R and the V vector become tangent to the curve. So when the delta T, the duration is very small, tends to 0, the variation delta R over delta T become derivative dr over delta T. So it's equal to dx over dti plus dy over dtj. So we obtain V vector equal Vxr plus Vyj. Then Vx, to obtain Vx, is the derivative of x with respect to time, and Vy is the derivative of y with respect to time. So the velocity vector at time t is defined as being the derivative with respect to time of the position vector. So Vt is the derivative of position vector om prime equal dom over dt, or Vt equal x prime ti plus y prime tj. Magnitude V equal radical Vx square plus Vy square, such that Vxt equal x prime and Vyt equal y prime. The instantaneous velocity vector is always tangent to the trajectory and oriented in the same direction of motion. It's very important. Its instantaneous velocity vector has a ut vector, unitary tangential vector, and un is the unitary normal vector, while ut vector equal v vector over v. V vector over magnitude of V. Application 5. We consider the following position vector in the frame OIJ. RT equal OMT equal 5t square minus 3i plus 2t plus 1j. Part A. Determine the velocity vector V vector. V vector, it's equal to R prime t. So it's equal the derivative of this quantity. The derivative of 5t squared, it's equal to 5 times 2t, the derivative of t squared, it's 2t, minus 0, I, plus the derivative of 2t, it's 2, plus the derivative of 1, it's 0, so it's equal to 2j. So we obtain V vector equal 10t I plus 2j, where Vx it's equal to 10t, the component before I, and Vy it's equal to 2, the component before j. Part B determines the velocity V, so its magnitude. V equal radical Vx squared plus Vy squared, it's equal to radical 10t square plus 2 square, we obtain radical 100t square plus 4. Part C, find ut. Ut vector, it's equal to v vector over v magnitude of v. It's equal v vector equal 10ti plus 2j over radical 100t square plus 4. Acceleration vector. A vector it's equal to delta v over delta t. It's equal to if ai at any position I, it's equal to vi plus 1 minus vi minus 1 over delta t. So by representation, let this point it's mi, this point it's mi plus 1, and this is mi minus 1. First, we represent the instantaneous velocity at mi plus 1. The instantaneous velocity vi plus 1, it's tangent to the curve and with the motion. So this is the vi plus 1. And vi minus 1, it must be tangent to the curve and to the trajectory and with the motion. So this is vi minus 1. vi plus 1, we represent vi plus 1 at mi. So we translate vi plus 1 from mi plus 1 to mi. We obtain this curve. We translate parallel and of same direction. Minus vi minus 1, so we translate this vector parallel but in opposite direction since we have minus. Then vi plus 1 minus vi minus 1, we obtain these two vectors. So the results of these two vectors is the diagonal of a parallelogram. Then this is delta v. Therefore, AI vector has the same direction as delta v. So this is AI vector. The acceleration vector at an instant t defined as being the derivative with respect to time of the velocity vector at this instant. So at equal v prime equal m double prime vector. So at equal v prime xi plus v prime yj. Magnitude of acceleration vector a equal radical ax square plus ay square, such that axt equal vx prime and ayt equal vy prime. The instantaneous acceleration vector is always directed to the interior of the trajectory, like this. Representation of acceleration vector ai. We represent the velocity vector vi minus 1 and vi plus 1 at the points mi minus 1 and mi plus 1 respectively. So this is vi plus 1 and this is vi minus 1. Then we represent the vector delta v, vi plus 1 minus vi minus 1 in the preceding manner. At the point mi, we represent a vector parallel of the same direction and the same length as vi plus 1. This is this vector. Then a vector directly opposite to vi minus 1. And this is the vector directly opposite to vi minus 1. Delta v is the results of these two vectors, is the fourth point of a parallelogram. So it's along the diagonals of the parallelogram. So this is delta v. The acceleration vector is parallel and in the same direction as delta v, like this. The magnitude of the acceleration ai, it's equal to magnitude of delta V over 2 tau. We measure using the ruler lengths of delta V, and using the scale of speeds we find the value of magnitude of delta V, then we calculate AI. Application 6. We consider the following position vector in the frame OIJ. RT equal OMT equal 2t squared plus 1i plus 5t minus 3j. Part A. Determine the acceleration vector. First, v vector is equal to r prime. So the derivative of r, 2t squared plus 1, its derivative it's equal to 4ti plus the derivative of 5t minus 3, it's equal to 5j. So this is the velocity vector. The acceleration vector, a vector, it's equal to the derivative of v vector. So the derivative of v vector, it's 4i plus 0j. Part B, determine its value. A, the magnitude of A, it's equal to radical ax square plus ay square. While ax it's equal to 4 and ay it's equal to 0. So we obtain radical 4 square plus 0 square, it's equal to 4 meter per second square. Part C, deduce the type of motion along the two axes. Along y prime y, ay it's equal to 0. So it's URM, uniform rectilinear motion. Along x-axis, x prime x, ax is equal to 4, so it's UARM, since a it's positive. In the plane motion, the acceleration vector has two components. Tangential acceleration AT, a component tangent to the trajectory, which is the measurement of the variation of the magnitude of the speed with respect to time. It's then the derivative with respect to time of the magnitude of the velocity. So AT, the tangential acceleration, is equal to the derivative of the magnitude of the velocity. In this case, we need to use the derivative of radical u. Radical u, it's equal to u prime over 2 radical u. In this case, if the motion is accelerated, then v is increasing, hence at it's positive, and at vector is oriented in the direction of motion. If the motion is decelerated, then v is decreasing, hence at is negative, and at vector is oriented in a direction opposite to the motion. Normal acceleration an, a normal component is directly always towards the inside of the trajectory and depend on the speed v of the book and radius r of the trajectory, such that an is equal to v square over r, and we have the relation a square equal at square plus an square. This is AI, the A vector. AT vector is tangent to the curve along UT vector, and AN it's a vector perpendicular to AT. The summary until now. Position vector its r equal xi plus yj. Parametric equation x equal and y equal the component before I vector and the component before j vector y. Trajectory equation its equation independent of time. Maybe it's a line of equation y equal ax plus b, or parabola of equation y equal ax square plus bx plus c, or circle of equation x minus a square plus y minus b square equal radius power 2, circle of center AB and radius r. Radius r. Distance OM equal radical x square plus y square vector displacement delta r, it's equal to r final minus r initial, average velocity v average equal delta r over delta t, velocity vector v equal r prime, the derivative of r, it's equal to vxi plus vyj. After derivative, this is vx and this is vy. Magnitude of velocity equal radical vx square plus vy square. Average acceleration A average equal delta v over delta t. Acceleration vector A vector equal v prime, the derivative of v, it's equal to axi plus ayj. Ax is the derivative of vx and ay is the derivative of vy. Magnitude of acceleration A equal radical ax square plus ay square. Tangential acceleration At equal derivative of the magnitude of velocity, so derivative of speed. In this case we use derivative of radical u, it's equal to u prime over 2 radical u. Normal acceleration an it's equal to v square over r, or a square, we have a square equal at square plus an square, so we obtain an square, it's equal to a square minus at square. Radius of curve, we can use an equal v square over r. Tangential acceleration vector, at vector, it's equal to at times ut vector. Unitary tangential vector, ut vector equal v vector over magnitude of velocity. Note, if at equal to 0, so an equal to a, in this case the motion is uniform circular motion. If an equal to 0, so a equal at, in this motion radius equal infinity, so the motion is rectilinear motion. Note that the derivative of sin u, it's u prime cosine u, and the derivative of cosine u, it's minus u prime sine u. If the acceleration vector parallel to x-axis, in this case ay equal to 0, and if the acceleration vector parallel to y-axis, in this case ax equal to 0.